So I've had some people ask for help on question 8.66. Draw the 4 possible Lewis structures of xenon trioxide with 1, 2, 3, with all single bonds, 1 double bond, 2 double bonds, and 3 double bonds. So we're going to start with xenon in the middle, and then we want to bond with oxygen. So each of them are xenon trioxide, so we're going to form 3 bonds with oxygen for all 3 of these Lewis structures. So that's the next thing we want to do. And then after that, we want to make sure that we've got our 1 double bond, our 2 double bonds, and then our 3 double bonds. So we'll just start here. So here's 1, 2, 3 double bonds, here's 1, 2 double bonds, and then here's 1 double bond. The next thing we need to do is we need to fill our octets. So oxygen wants 8 total electrons in its octet, so this oxygen currently has 4. Now we're going to do a pair of electrons each. You never want to do 1 electron at a time unless you have a radical where you only need 1 electron. So here's our full octet for that oxygen. Here's our full octet for that oxygen. Here's our full octet for that oxygen. I'm just clicking twice to give it 2 lone pairs of electrons. This oxygen as well already has 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. This oxygen only has 2 electrons, and so to fill our full octet for this oxygen, we need to add 6 more, so 3 more pairs. So 1, 2, 3, 4, 5, 6, and 7, 8. And we'll do the same thing down here. We need 2 more pairs. Here we need 3 pairs, and here we need 3 pairs. And then in all of these we need 1, 2, 3 pairs of electrons. And then the last thing we want to do is we need to, so when we made this Lewis structure, xenon came with 8 electrons, oxygen came with 6 electrons each. So if we accounted for all of our electrons, we'd see we've got 2 more electrons left to account for. So we'll put them on the central xenon. So there we've accounted for all the total electrons we need to account for. And then finally, the last thing we need to account for are formal charges. And our formal charge is our group number minus the number of assigned electrons. So assigned electrons is 1/2 the bonding electrons plus all of the non-bonding electrons. So if we were to look at this oxygen here, we've got 1, 2, 3, 4 non-bonding electrons plus half of these electrons here, so plus 2 more. So it's got 6 electrons assigned to it. It's group 6. 6 minus 6 is 0. So there's no charge on this oxygen. Xenon is group 8. It's got 1, 2, 3, 4, 5, 6, 7, 8 electrons assigned to it. There's no charge on xenon. However, if we look over here, we'll see, oxygen is group 6, so it's domain 6, and it has 1, 2, 3, 4, 5, 6, 7 electrons, because half of these bonding electrons here assigned to it, so 6 minus 7, this oxygen should have a negative charge. And you'll notice that anytime oxygen has 3 lone pair electrons, it will always have 7 electrons assigned to it, and it should have a negative charge. So we'll have a negative charge here, a negative charge here, a negative charge here, a negative charge there, and a negative charge there. And now you'll also notice the bonding with xenon change because we have 2 double bonds and 1 single bond. So what's the formal charge on xenon? It's group number 8, and it has 1, 2 lone pair electrons plus 3, 4, 5, 6, 7 electrons assigned to it. So 8 minus 7. Xenon should be plus 1 in this case. Here xenon has 2, 3, 4, 5, 6 electrons assigned to it. So 8 minus 6 should be a charge of plus 2. So all I did was get the plus and click xenon twice. And then the third and final case, xenon has 1, 2 lone pair electrons, 3, 4, 5 bonding electrons for a total of 5 electrons. It's group 8, so 8 minus 5 must have a charge of plus 3. And so hopefully, fingers crossed, that gives us the right answer for all the configurations of xenon. Any day. And so naturally my computer had to freeze, but that is the correct answer with the formal charges assigned. So don't forget your formal charges on oxygen and xenon. The next question down, of any of these resonance structures, which of them satisfy the octet rule for every atom in the molecule? And of which of these structures, where are there only 8 electrons assigned to all of the outer elements? And that would be 8 total electrons. So that would be xenon 3+ here. Every element here has a total of 8 electrons in its valence shell. So yes, the structure with one double bond, or sorry, the structure with no double bonds fits the obeys the octet rule. And then, do any of these 4 Lewis structures have multiple resonance structures? Yeah, a lot of these Lewis structures have multiple resonance structures. But to have a resonance structure, you have to have double bonds. So the only available ones that can have resonance structures would have 2 double bonds or 1 double bond, because then we can move those lone pair electrons around. If we have all 3 double bonds, we can't move those electrons anywhere, there's no vacancy. And if we have no double bonds, there's nothing to move. So only those 2 have extra ones. And then the last, I'll let you figure that one out. I can't give you the answer to everything.